Okay, so what do we see here? I found this TV on garbage. The screen was broken, and then I thought, why not to take the LEDs from the panel, because it's look like a new TV. It's not an old one. It's a very big one. I guess something about 50-inch. I took all the reflections out. I took it apart. You have all this you can use, but the voltage is too high, so it's a waste of time trying this way to light them up. But I will take them off. There are screws here. You can see here another reflector. This is just a paper. Beneath there is the metal, and you have also lenses for each LED. And it looks like only 4 strips. How can I see it? Because I have here 4 connectors. This one for 1, 2, 3, 4, 5, 6, 7 LEDs. So each strip is 7 LEDs. I will try to tear them down and see how if I can light it up, and I will not use it because it's much too big, and we'll see what I can do with it. Okay, so now I took all the screws, and there were this spacer from the main sheet, the reflector. So now I will try to take it out. By the way, this is stick, it's glued. The PCB of the LED is thick. So let's see how difficult it is to take it out. So the reflector is out, and as you can see, there are the LEDs connected with each strip have 7 LEDs. How to take it off? Let's see. We have the tape here. Try to take it off. I'm sure it is also glued to the metal. The metal, this is like an heat sink, maybe the LED get heat. So now I can disconnect all the connectors out. All connectors are out. So now we'll be able to use a screwdriver to take it out. It's not easy. But it is possible. It's not glued on. I see the way, just a few spots. Just using regular flat screwdriver. So this is the strip of the LED. Okay. Here are the places where it is stick to the main frame. So now I'm curious about this LED voltage. Probably I'm not sure if they are connected, maybe all in parallel or in serial. This is a good question. By the way, there is a barcode here on the LED, a Q code, so you can scan it and have probably the same LED. We will try it in a minute. So let's remove all the LEDs because I don't need a metal frame. Of course, nothing to do with it. These are the tapes. now I know better how to disassemble the next one. The first is a little hard. But then just go with a little force. Okay, maybe you can also use a knife or like this phone tool. Yes, this is better because it's very sharp, and I don't know if I've ruined some of the LEDs. So let's move to the other side. These are all the tapes and all the cable, connector cable. Let's snip it up. It's not really heavy. So we can do the same here. Now I know a little better how to start. You can see that the sticking point is exactly beneath the LEDs because these are the places that you want to spread the heat, so this is the best place to put. Probably the sticker also is a heat spreader, heat sink. Another one is out, and the last one. Again, removing all the tapes. And the same for the last one. So now all LEDs are out. Now we'll try to light them up. So here is the strip, it is now connected. I found the voltage. It's about 50 volts. I will show you, I'm using it here a power supply, so I can connect it directly. There are 2 points here marked as plus and minus. It's a little hard to see, but I will show you it. And it is lighting, so we'll connect now. Beware 50 volts, if you touch it you will feel it because the voltage is high enough to get electrified. Okay, so you can see the LEDs are lighting. By the way, each LED is about 5 volts. I can show this also. Let's put 5 volts, and I will limit the current. I think 100 milliamp is okay. Now each LED has a place you can touch. It is marked as minus, so if this is minus, so this is the plus. So each LED that you connect the minus in the correct way, so we light it up. Let's see if this is working. I will limit the voltage to 5 volts, 100 milliamps, and now, so if this is the minus, so this is the plus. Sorry, one power supply is connected but the other is not, because they're in serial, so let's fix it up. So these are the two wires that I currently need. So this will be the plus. I can use the crocodile I have. So if this is the minus, this will be the plus. If it is not lighting, maybe it should be a little above 5 volts, maybe 6 volts. Or maybe it is like this. I need to connect it. Yes. So 6 volts, it works fine. So you can separate the LEDs with a knife and use each one for a flashlight or something you need. I'm a little curious, so I will try to find the spec, if I will know what is the wattage of each LED, so I can calculate what is the voltage and the current that I need to apply to it in order to make it work. So that's all for now. Bye. Okay, so now I will apply 47 volts to the LEDs. I think this is the correct voltage. There is, as you can see, it is lighting. There are test point on the side. I'm applying now 50 milliamps, so it is limited. I will check the voltage. Voltage is 37 volts. Okay, so let's get to 37 volts. So one would be 20 volts, and now let's check. Okay, so let's apply another volt. So now it is 38 volts for this panel. Why it is not lighting? Sorry, I did a mistake. 20 volts, and this one should be 18 volts. Now this is 38. Let's up the current for 100 milliamps. Okay, so now the current is a little higher. Let's check the other one. Okay, here I have a broken LED, so one strip is not lighting, but this is working okay. This one is not lighting, you see. What you're seeing was reflection. So this is the working one. So voltage about 38 volts. Let's divide by 7. 38 divided by 7. So each LED is about 5.5 volts. These are the numbers. That's all. Bye.